The new section is entitled Estimating a Population Proportion. Suppose you are asked the following. It says find the critical value. Find critical value, which is denoted by z sub alpha over 2 for 90%. No, for a 90% confident interval. So basically what this is saying is that this tail over here and this tail over, okay, let me say it slightly different. It's saying what's in between those two tails is 90%. What's in between the two tails is 90%, which means there's 10% for the tails, which means 5% goes here and 5% goes there. And of course 5% is 0.05. And z for 0.05, if you look it up, it just happens to be 1.645. Now, depending upon your z table, it might tell you up to some value. Well, we want 90%. And again, if you look up 90%, you will get 1.645. And I should be very clear. If you look up 0.05, you will discover that the z value is negative 1.645. But we always say z with the positive value. Instead of negative, we take the absolute value. We take the absolute value. Okay, if we were to do another one exactly like this, the only change would be, of course, is the level of significance. Suppose we wanted a 99.5 confident interval. 99.5. Well, 1 minus alpha is always 1 minus 99.5, the confident interval percent. That is 1 minus 0.995, which is going to be 0.005. I like to put another 0. So alpha divided by 2 would be 0.0050 over 2. And we're going to get 00, those two zeros, and half for 50. 50 divided by 2 is 25. And if you looked up that chart, you should get 2.81. 2.81. If you look up this number inside the table, here's the table, inside look up 0.0025, and to the left you'll see 2.8. You'll see 2.8, and right above it 0.01. 2.81. So it's rather simple to find the critical values. Now the next one, I suspect a lot of students will not like. It's really pure math. Suppose you were asked the following. Suppose you were asked to express the confident interval. See a good one. Say 0.700 is less than p is less than 0.990 in p plus or minus p hat plus or minus e form. Suppose you were asked that. Okay. So what you want to know is, need to know what P is. P is the number in between this number and that number. It's right smack in the middle. Now there's two ways of doing it. You can add up the two numbers, and you could then divide by 2. When you divide this by 2, you get 0.800. And that's what P is. This is P. Or you can be slick. 0.7, 0.9. Point. What's in between 7 and 9? 8. So P is 0.8. Okay, add up the two numbers, divide by 2, or figure it out in your head. Now we know what P is. Now, remember, this must be P plus E. If you prefer, that one's P minus E. So you know that P plus E is equal to 0.900. But we know what E is now. It's 0.800. E is 0.800 plus some number gives you 0.900. There's many, many ways to do it. Personally, I like to do it this way. Nobody but nobody does it this way, but in my opinion, this is the cleanest way. We want to add two numbers. The second one we don't know, and we want to get 0.900. Well, 0 plus 0 gives me 0. I have 0 here. I add another 0, I get 0. I have 8 here. I add 1, that gives me 9. So 0.100 is my answer. That's one way of getting 0.100. Another fairly easy way is 0.8 plus 0.1 is 0.9. Either way, E is 0.1 or 0.100. The way you were probably taught to do it, the non-thinking way, is to take away the 0.800 and you're left with plus E or E. And the right side you subtract, you get 0.100. Okay, so now the problem said write it in P hat plus E form. I guess I made one slight error. P hat is 800. So the answer, or 0.800. So it's 0.800 plus minus E, which is 0.100. And the answer's done. Let's try another one just like that. In fact, let me keep everything. Okay. So all that changes is what P is in between. Actually, how about we try this one instead? It's just going backwards. We started with one notation in the last problem, and we wrote it in our new notation. Now we're going to start with the new notation and write it in the old notation. If you have 0.37 plus minus 0.050, you want to express that in P hat minus E is less than P, which is less than P hat plus E notation. Well, just like before, this is P and that's E. P hat, excuse me. That's P hat and that number is E. Okay, so it's P hat 0.37 minus 0.050 is less than P. You know, P hat is 0.437, minus is minus, E is 0.050, less than, and then P, and then less than, and P hat is 0.437 plus, and E is 0.050. Now we just do the math. This math right here, 0.437 minus 0.050. This, of course, will give me 387. And over here, we do this math. 437,050. Add, this gives me 0.487. So P is in between 0.387 and 0.487. Okay, let's try another mechanical problem. We'll do some mechanical problems from this section, then we'll do some word problems. Oops. Okay. Supposing you're given the confident interval. Given the confident interval, 0.0244 is less than P, less than 0.982. Question asks to find P and E. Well, P is the number smack in between these two. So you add them up. It's the average. P is 0.0244 plus 0.0982 divided by 2. So let's add them up on the side here. And then right afterwards, we'll divide by 2. So we get 6, 12, another 12, 1. 0.1226. Well, when you divide that by 2, 2 into 0.12 is 0.6. 2 into 26 is 1.3. You want to do it the long way? Go for it. Not a big deal. 2 into 1 goes 0 times with 1 left over. 2 into 12 goes 6 times. 2 into 2 into 2 goes 1 time. And then 2 into 6 goes 3 times. So however we do it, we get that answer. And that's P. Like always, this number is P minus E, and this number is P plus E. You need to know that. You need to know that P is in between P hat minus E and P hat plus E. So again, our typo. Those are P hats. So the problem asks, if I didn't say it, I don't think I stated the problem, I'm sorry. The problem says, given that confident interval, find P hat and E. Sorry about that. So we found P hat. Well, actually, no. First it says to find P and E. Well, we found P. Now we need to find E. Now we need to find E. We need to find E. Well, that's also P plus E. You know that P plus E is 0.0982. And you know P is 0.0613. So let me write that, 0.0613. And you add E to it, and like magic, you get 0.982. Well, 0.0613 plus a number that I admit I don't know. Let's line up the decimal. And we're supposed to get 0.982 when we add it. Well, 2 plus nothing gives me, 3 plus nothing gives me 2. But 3 plus 9 gives me 12. Bring down the 2, carry the 1. So far, this is 2. Add 6 more, get 8. That's 6. Add 3 more, get 9. That's 0. Add 0, get 0. E is 0.0369. You just hate what I did? Subtract 0.613 from both sides. On the left side, you just get positive E. On the right side, you get 12 minus 3 is 9, 7 minus 1 is 6, 9 minus 6 is 3, 0 minus 0 is 0. 0.0369 is E. So in fact, we found P and we found E. And excuse me, I don't know why I'm just saying this wrong. We wanted to find our P hat. So we found P hat is 0.0613, and we found that something's still disturbing me here. Excuse me a moment. Yeah, we're going to get the same answers, but possibly we could have done it. We probably should have done it this way. It's exactly the same, but I'll be using the correct notations. The left number, 0.0244, that's P hat minus E. This is 0.0244. The right-hand number, 0.0982, this is P hat plus E. Well, for example, if we add these, negative E plus positive E cancels, but the P hat plus P hat is 2 P hats. You add the right side, you get 0.1226. You divide by 2, you'll get the same answer I got before. That's P hat. Okay, and using, say, this equation, we know that P hat, which is 0.0613, plus E gives me 0.982. And this is exactly what we did do. 3 plus 9 ends in 2, carried 1. 2 plus 6 gives me 8. That 6 plus 3 gives me 9. 0 plus 0 gives me 0. So that's E. And we use the right notations. Sorry about that. Okay, so suppose we want to find the margin of error. And you are told that n is 500. N is 500. And you are told that x is 200. And you want a 95% confident interval. You want 95% confident. Okay, you want a 95% confidence. And the problem says find the margin of error. Well, this is 200. The margin of error is E is equal to Z, sub alpha over 2, times the square root of P hat Q hat over N. So basically, we just need to plug in the right numbers. Okay, so the first question is, what is Z alpha over 2? Well, alpha is 1 minus the confident level. 1 minus 0.95 is 0.05. I got 0.95 from 95% confidence. And then you divide it by 2. Think of that as 0.050. Divided by 2, you get 0.025. And it turns out that 0.025, let's look at our trusty table. .025 is 1.96. This corresponds to 1.96. Okay, so z sub alpha over 2 is 1.96. And we take the square root. Well, p hat, by definition, is x over n, as opposed to n over x. It's x out of the n. N is 200, x is 200, n is 500. It's just 2/5 or 0.4. So therefore, q hat, well, if you have success 2 out of 5 times, you must fail 3 out of 5 times. 2 successes, 3 failures. So q is, I meant to say p is 2/5, q is 3/5, and n is 500. And if you crank out these numbers, you should get 0429. 0429. 0.0429. That's what E is. If you know E, you can do things with it. Like you can find the confidence interval, which we'll do in a little bit. Now, suppose you want to find the sample size. You want to determine the sample size. Now, there are 2 situations. When you know p hat and q hat, or when p hat and q hat are unknown. So, suppose I tell you that the margin of error, that is E, the margin of error is 0.020. And I tell you that the confidence level is 95%. And that's all I tell you. And I say determine the sample size. So p hat and q hat are unknown. So you could approximate n using this formula. Z sub alpha over 2 quantity squared times a constant, 0.25, a quarter, divided by E squared. Well, they told us what E is in the second line. They said the error, the margin of error is 0.02, 0.020. Square it. Why? Because the formula says to square it. And Z alpha over 2. Well, alpha is 1 minus the confidence interval. 1 minus, and confidence interval is 95%, which is 0.95. And 1 minus 0.95, $1 minus 95 cents, it leaves you a nickel, 0.05. But there really are no units. But putting in units will never hurt. Just don't give the answer in units. Somebody asks you what 2 times 5 is, don't say 10 square feet. Say 10. Okay, well, we have to divide it by 2. If I divide one side by 2, I have to divide all sides by 2. Equal signs have to be valid. And once again, this is 0.025. And this corresponds to the value of 1.96. So I'm back to this formula on top here. Z sub alpha over 2 is 1.96. I am asked to square it, then multiply it by 0.025, which apparently I can't write. 0.25, and then divided by 0.020 squared. And you crank this through, and you should get the magic number 2401. You need to round up if need be. If you got 2400.3, you round it up to 2401. If you get 2400.72, you round it up to 2401. Because it requires this amount or more to live up to the 95% confidence interval. Since we couldn't possibly survey or come up with a sample of 2400.72, you have to round it up to 2401. Okay, so that was a case where you were not given P hat and Q hat, nor could you easily figure it out. So let's do another one where it's going to be given. Let's do another one where this information is known. Suppose, or can easily be obtained. Suppose the margin of error is 0.05, 5%. And the confidence level is 90%. And you come to learn that P hat is 0.65. Remember 90%, remember as 0.90. And if P hat is 0.65, that Q hat must be 0.35. So they have to add up to 1. 0.65 plus some number should give you 1.00. Well, 5 plus 5 gives you 10, which ends in a 0 carried a 1. This is 7. Add 3 more, it ends in 0 carried a 1. And 1 plus 0 gives you 1. 0.35 is Q hat. And instead of having that constant 1/4 or 0.25 in the formula, we now have P hat and Q hat. N is Z sub alpha over 2 times, all squared like before, but now instead of timesing by 0.25, we multiply by P hat times Q hat. And we still divide by E squared. Well, E they told us, the second line here, the margin of error is 0.05. So I'm just going to jump on that one. And we know P hat and Q hat, they're in this fourth line right here, 0.65 times 0.35. The only thing we don't know yet is Z sub alpha over 2. But I do know that whatever it is, they're asking me rather than isolate to square it. So the confidence is 0.9. So alpha is 1 minus 0.9 or 0.90. I mean, think of $1 minus 90 cents. You all know that that's 10 cents. Okay, and then get rid of the units. It's 0.10. Divide by 2 because that's what it says, alpha over 2. And if you think of that as a dime and you divide it by 2, you get a nickel, 0.05. But what does that correspond to? The answer is 1.645. This 1.05 is one of those numbers that is right in between 1.64 and 1.65. So what's in between $1.64 and $1.65? $1.64 and a half. But no matter what, it should say on your Z table in the bottom, next to an asterisk, that 0.05 is 1.645. That's the Z-score, 1.645. And when you multiply those numbers and square some of them, you get 247. If you use a sample, if the margin of error is 5% and p hat is 0.65, and you want a 90% interval, you better use at least 247 people. Your sample size better be 247. They don't need to be people. They can be light bulbs. Excuse me. They can be voters. They can be people, but special people, voters, kindergarten students, statistics students. Now, there is this rumor, which personally I don't believe, that says that people who are about to die, that they can live a little bit longer if things are important for them. If things in the future are important to them, like a wedding, their kid's wedding, the birth of their grandchild, their birthday, they can try to prolong their life. Now, let's talk about Thanksgiving. People may want to make it through Thanksgiving because they're going to meet with their family and their loved ones, and they'd really be excited to make it, or at least they'd like to attend. Okay, so suppose that the total death 1 week before and after Thanksgiving. Before and after Thanksgiving is 12,000. That is, 12,000 people died within that 2-week span. Right before Thanksgiving, right after Thanksgiving. Okay, and suppose it is 2 P's, believe it or not. Suppose 6,062 people died before Thanksgiving. Died the week before. The week before Thanksgiving. Okay, which is more than half. That's why I don't buy this. More than half the people died before. Maybe trying to live longer is not a good thing because you'll live shorter. Okay. Now, the problem says to construct a 95% confident interval of the proportion of death. So the proportion of this and that. So the proportion of death in the week before Thanksgiving to their total death, in the week before and after. The total death in the week before and after Thanksgiving. So confident interval. That means we need to know p hat minus e, and we also need to know p hat plus e. That is, we need to know p hat and e. We know the two, we can surely subtract them and add them. Well, p hat, we want the proportion of the people who died a week before, which is 60,60,02, to their total death in the week before and after, which is 12,000. And it turns out that this is 0.5052. So wonderful, we have p hat. I'd give you a third of the credit for that. You have p hat, that's 1/3, getting e is 1/3, and then subtracting them and adding them is another third. Well, turns out that q hat will be, well, what's 1 minus that? Or what do you add to 5052? What do you add to it to get 1.0000? Well, 2 plus 8 ends in a 0. It's 10, carry to 1. This is 6. Add 4, get 10, carry to 1. This is 1. Add 9, ends in a 0, carry to 1. And 1 plus 5 is 6. You add 4, you get 0, carry to 1. So it's 0.4948. Or you do 1 minus p. Q hat is 1 minus p. However you do it, you do it. Now, you may be saying, well, why are you getting q? Well, maybe I should have stated why. I will in one moment. First, let's write it down nicely. 4948. 4948. The reason is because to get e, I need p hat and q hat. Remember, e is z sub alpha over 2 squared times p hat times e hat. Well, actually, this is a new formula. This is the formula to get e. And that should be a q. And that should be an n, excuse me. Okay. This is how you get our e. So once we have once we have e and p hat, we're kind of done. Now, the thing is, what is z alpha over 2? Well, alpha, we want a 95% confidence interval. So alpha is 1 minus 0.95, which is $1 minus 95 cents, which is a nickel, which is not 5. It's 0.05. Divide by 2, you get 0.025. And 0.025 is 1.96. So this is 1.96. Z sub alpha over 2 is 1.96. If you look on the table for 0.025 and then read the left column and the top column, you get 196. And then you multiply this by p hat, which is p hat, which is right above, 5052, times q hat, which is 4948, decimal 4948. Divide this by 9, which is the 12,000 deaths before and after. And you will come out with 0.0089. 0.0089. This is E, and I'm going to put P hat right here. It's 5052. And the rest I need to get rid of. Remember, my confident interval is going to be p hat minus e is less than p, which is less than p hat plus e. So let me do p hat minus e. 0.5052 minus 0.0089. You borrow, you get 3. You borrow again, you get what? 6. 4963. And then you add them. 50, 52 plus 0089. Get 11. You get 14, 1, 5, 1, 4, 3. So let me just erase this. Actually, here. The very bottom is your answer. There it is. That's your answer. You need to know that you want to find p hat and e. Let's try a couple more of these. It was found out that during an 11-year period in a city in Texas, 870 people served on a grand jury. Actually, they were selected for grand jury duty. But they served on a grand jury. And 39% of them were Mexican Americans. They were Mexican Americans. Mexicans. Okay. However, in the city, 79.1% of the people eligible for a grand jury were Mexican American. In the city, 79.1% of the people were who were eligible were Mexican Americans. So now you want to use this sample data. Now, why is it sample? Because it was only from an 11-year period. Use the sample data to construct a 99% confident interval. Confident interval estimate. Confident interval estimate of the proportion of grand jury members who were Mexican Americans. Mexican Americans. Okay. So they want the confident interval. They want p hat and they want e. We need p hat and e. because it's going to be P minus E is less, P hat minus E is less than P is less than P hat plus E. We just need to find the P hats and the P hat and the E. Okay, that's what you need to understand. That's all you need to find. And then you need to know to add and subtract them. P minus E, subtract. P hat minus E, excuse me. And P hat plus E. Okay, so now P hat is the Mexican Americans on the grand jury. It's 0.39. We need 39% of them. Well, that was pretty good because, boom, we have P hat. Well, Q hat, well, it's whatever you add to 0.39 to get 1. What do you add to 39 cents to get $1? The answer is 61 cents. 1 minus 0.39 is 61. So we need E now. The reason we wanted Q was to get E, because E is equal to Z alpha over 2 times the square root of P hat times Q hat. That's why we needed Q over N. Well, alpha is 99, what's 99%? So alpha is 1 minus 99%, which is 0.9. Well, that's 0.01, 0.010. And then when you divide it by 2, you get 0.005. It turns out that that translates to a z-score of 2.575. Okay, 2.575. That's z sub alpha over 2 times the square root part. P hat, Q hat over N. Well, P hat is 0.39. 0.39. Q hat is 0.61. Then you divide by N, which is should just look at the very beginning. 870 was the total number of people who served. And if you crank this out, you get that E is 0.04. So now we have E, and we have P hat 0.39. Erase most of this like I did last time, and just do it. And we should think in dollars and cents. P minus E. 39 cents minus 4 cents, that's 35 cents. You know that. Less than P is less than P plus E. 39 cents plus 4 cents, 39 cents, 40, 41, 42, 43 cents. Then you say next problem. Your teacher asks, where's your work? You're like, come on, I know what 39 minus 4 is. I know what 39 plus 4 is. There's some things that you should know. Okay. Next couple of problems will be word problems again, talking about or asking us to find the necessary sample size. We're going to be given some information. Some of it is what we want, like a 90% confident interval or a 99% confident interval. The question is, how large should N be? As you probably know, many states are trying to figure out ways to collect sale taxes on items that are purchased through the internet. You go to the internet, you buy something from somebody in the state of Utah. Well, normally if you went to Utah and you bought this item, regardless of where you live, normally, you might be on vacation in Utah, regardless of where you live, you pay the local sales tax. Okay? You go from one city to the next, sales tax may be different. You can say, oh, I'm from, 3 miles away, I pay a little bit lower sales tax. They're going to say, well, go shop in there. Okay, so when you buy something in the state of Utah and you live in California, you know, in theory, you really should be paying sales tax. And the states are losing a lot of money. A real quick story is baseball players, basketball players, etc., that they make a lot of money. And you know, maybe they make $20,000 for each game that they play. Well, you know, you play for the San Francisco Giants and you go to New York to play and you earn $20,000. Well, New York is getting wise and is starting to tax these people on their income that they made while they were working in New York. Okay, so states are trying to collect money on items that are purchased through the internet. So the question is, how many randomly selected transactions, must be looked at, must be surveyed let's see, to determine, let's get a market that works, that would be helpful. To determine, there we go, the percent that were purchased through the internet. Assume you want a 99% confident, you want to be 99% confident that the sample percentage is within 2 percentage points of the true population percentage for all sales transactions. Okay. Assume you, meaning the state government, want to be 99% confident that the sample percentage, is within 2 percentage points of the true population percent for all sales through the internet. That's not true. For all sales transactions. For all sales transactions. So how many randomly selected transactions must be surveyed to determine the percent that were purchased through the internet? So basically, you're going to randomly select some number, and that's to be determined, of transactions. Okay, you're going to go to a company, and you're going to say, show me your last, and that's what we have to figure out, how many, your last 2,000 transactions. Some are going to be from customers who bought it through mail order. Well, let's not go there. Some of them are going to be, most of them actually, are going to be bought from or by people who came into the store and purchased it. And then there's going to be some who purchased through the internet. And I guess when they say randomly selected, that doesn't mean they're going to go to one store. They're going to pick, I don't know, X number of stores, and they're going to tell each of them, you know, they're going to get some survey. They're going to get 20,000 different transactions. They're going to see how many were purchased through the internet. And the question is it 20,000 or 10,000 or 289 that they have to get? If they want to be 99% confident that the sample percentage is within 2% of the true population percent for all transactions. Okay, they want to make sure that this sample is really, really close to their percentage of people who buy stuff over the internet. The total true percentage. Okay, they want to be within 2% of that. Well, n is equal to z sub alpha over 2, all squared. Now, since we don't know p hat and q hat, we use the 0.25 number, and then we divide this by e, which is 2%, 0.02 squared. And if you're 99% confident, that means 1 minus alpha. I hope I haven't been writing alpha minus 1. That's pretty bad if I have. Sorry if I have. Actually, I know what I've been writing. But I have been writing 1 minus. Alpha is 1 minus the confidence level, which is 99%, which is 0.01. Divide by 2, you get 0.005. And it turns out that 0.005 corresponds to 2.575. So we get 2.575 squared. We get z sub alpha over 2 squared times 0.025. Now that we have, that was the only thing we had to find. The 0.025 is a constant. It's always 0.25. Unless you know p hat and q hat. And we had her kind of surf the 0.02 out of the problem. E is 0.02. Oh, here, let me actually write that. So it's divided by e squared. And we know that e is 0.02. And if you crank out this number, you'll get something like 4144.140625. But you can't survey a fraction of people. You can't survey a fraction of people. So you have to bump this up. That is, just add 1 there. You should survey 4,145 transactions. Let's consider another problem. And you know, for the state, this is really good. They know to survey only 4,145. They won't survey 20 million. Nor will they only survey 1,200. Okay, this costs money. I'd rather hire somebody to spend the 2 minutes like I just spent to realize that you only have to survey a little over 4,000 people than to just randomly pick 20,000 people, or transactions, excuse me, and then go about paying for that survey. Surveying 20,000 is a lot more in cost than it is to survey a little over 4,000. Okay. Now, we're going to talk about the auto industry. Volvo is considering to offer an option on their new cars. The option is going to be sunroof and a CD stereo radio for $2,000. The option is for both the sunroof and the CD radio. It'll cost $2,000. Okay. Now Volvo wants to determine the percentage of buyers who will pay the $2,000 for this option. Okay, Volvo they want, as opposed to wants, they want to determine the percentage of buyers who would pay their extra $2,000 for this option. This option being their sunroof and the CD radio. Question is then, how many people should they ask? How many buyers must be asked? You know, you go to people before you offer this option. You go to people who are buying the Volvo and you say, look, you know, we're not offering it to you because it's not an option yet, but would you buy it? Okay, how many buyers must be asked, surveyed, if they want to be 95% confident that they get a good result within a few percentage. Do you want to be 95% confident that the sample percentage, maybe 22% of the people surveyed would want to buy this? And hey, or 25, that's 1 in 4, 1 in 5. The people would want to pay an extra $2,000 for the car. Of course they're going to jump at that opportunity. But you want to make sure that your survey is good. In other words, you ask 2 or you ask 5 people, and 4 out of 5 say, yes, I want it. Well, that's 80%. But the problem is that the sample size doesn't mean anything. Okay, you'll be within 40%. Your error can be within 40%. But you don't want that. You want it to be within 4% of the of the true population. You want to be within 4 percentage points for all Volvo buyers. So what should N be? How many people should you survey? Okay. Well, once again, you're not given P hat and Q hat. So N is equals Z sub alpha over 2, and instead of times P hat, Q hat, it's just 0.25 divided by E squared. Well, confident level is 95. Alpha is 1 minus the confident level, which is 0.05. So alpha over 2 is 0.025. And 0.025, that comes up with a z-score of 1.96. But I'm going to check that out for one moment, please. Okay, so 1.96. So we have 1.96. That's that number times 0.25 times E squared. Well, you want to be within 4 percentage points. 4% is 0.04. And if you multiply these two numbers on top, and then divide by 0.04 squared, you will get 600.25, which means that you should survey 601 people. Okay, why is that? Again, to be 95% confident that you are within 4% points of all Volvo buyers, you need to survey. There's some number that you can survey, and more. The more you survey, you'll be within 4%. In other words, if you're within 4%, if you survey 725 people, well, then you'll also be within 4% if you survey 825 people or 727 people. If this number works, anything above will work. Now the problem is, if you go down to 600, it probably won't work, because it has to be 600.25 to work. Well, of course, you can't ask 625 people, so you ask 601 people. And that's the answer. And that finishes this section.